So welcome to this topic, qualitative analysis. It is an independent topic from what we are doing, that is preparation of sorts. It also it is an important ingredient of practicals. It comes as a practical also, and but it also comes in theory. So the knowledge from here, you need to go with it in both. So the way it's going to be delivered is we're going to do three different types of tests. We're going to start with tests for cations, then also do tests for anions, then also do identification of gases. Let's get started. So actually I'll start with tests for anions. So how do we test for anions in solution? So there are certain anions that have been selected. The procedure to test for their presence is outlined, and the results should expect when they are present are also going to be given. So we're going to start with these two. So carbonate ion, of course, the chemical formula is this for the ion. So how do you test for the presence of carbonate ion? You just add any dilute acid. So you remember, carbonates react with acids to form salt, water, and carbon dioxide. So whatever, if a carbonate ion is present, we just add any dilute acid, and carbon dioxide should be produced. So the positive test results is effervescence occurs and bubbles of carbon dioxide gas are produced. So what happens is carbonate ion reacts with hydroxide ion to form carbon dioxide and water. So what effervescence is, I'm going to show you, but let's talk about chlorine or chloride ion. So for chloride ion, what you do is you add a few drops of dilute nitric acid to make the solution as acidified. So when you add a few drops of dilute nitric acid, what you do next is to add a few drops of silver nitrate. So what's going to happen is the silver and silver nitrate is going to react with chloride to form silver chloride, and silver chloride, it's insoluble, therefore it will come out in the solution as a precipitate. So the positive test result is a white precipitate of silver chloride will form according to this reaction. So go back to effervescence. So effervescence is this. So bubbles in a liquid are what are called effervescence. So the carbonate ion test will produce these bubbles, and these bubbles are bubbles for carbon dioxide. So the next one we're going to take a look at is iodide ion. So how do you test for iodide ion? So what you do is you add a few drops of dilute nitric acid to make the solution acidified, just like in the one for chloride. Then you add a few drops of aqueous lead to nitrate. So when you add lead to nitrate, the lead is going to the lead ion is going to react with iodide ion to form lead iodide. So lead iodide is yellow and it is insoluble, so a yellow precipitate of lead to iodide is going to form. So lead is going to act with iodide, forming this lead iodide, which is a yellow precipitate. Next we go to sulfate ion. So the procedure is you add a few drops, just like before, of dilute nitric acid to make the solution acidified, then add a few drops of barium nitrate. So barium nitrate, of course, the barium ion is going to combine the sulfate ion to form barium sulfate. So this is going to give a white precipitate of barium sulfate. And I hope we all know the precipitate in the previous lessons, what a precipitate looks like. So barium sulfate forming barium sulfate. Next is the nitrate ion itself. How do we test for its presence? So the procedure is you add a few drops of aqueous sodium hydroxide, then you add an aluminum foil. Okay, then you home carefully. So when you do this, you introduce red litmus paper into the test tube. Remember the indicator, red litmus paper. So you introduce the red litmus paper into the test tube, where nitrate ions, where you're expecting the nitrate ions to be, and where you have added these. So what's going to happen is it will turn the masked red litmus paper blue. It's going to turn the masked red litmus paper blue. And of course, ammonia gas is produced. So if a gas is going to be produced, if you can test this gas, you're going to discover that it is ammonia. We're going to start out to test for this gas. So sorry, this is repetition. So now we'll go to test for cations. We're done with anions. What about positively charged ions, cations? So for testing for cations, we use either aqueous sodium hydroxide or aqueous ammonia. So we use these two reagents, aqueous sodium hydroxide and aqueous ammonia, to test for most of cations. So two observations will help identify the cation present. The first is the color of the precipitate formed on adding a few drops of chemical reagent. So when you add a bit of sodium hydroxide or a bit of aqueous ammonia, the color of the precipitate should be able to tell you what kind of a cation it is. Secondly, the solubility of the precipitate in excess chemical reagent. So add a few drops to see the color of the precipitate, then we'll add more of either this or this. Then usually what happens is, if you add more, then the precipitate forms what are called complex salt, which either soluble or not. So the solubility of the precipitate in excess chemical reagent is going to tell you more about the cation. So let's take a look at some cations. So we start with these. So we'll start with aluminium ion. So first we'll see what happens when you add aqueous sodium hydroxide. Aqueous sodium hydroxide. So when you add aqueous sodium hydroxide, a white precipitate is going to be formed, and this white precipitate is going to dissolve in excess, giving a KS solution. What about in aqueous ammonia? Again, a white precipitate is going to be formed, but it's going to be insoluble in excess or in excess aqueous ammonia. What about ammonium ion itself? So this one, when you add sodium hydroxide, ammonium gas is going to be produced when you warm the mixture. Okay, but since ammonium gas, we can't again add ammonia. Even if we add ammonia, nothing is going to happen, so don't do any test here. So go to calcium. So for calcium ion, a white precipitate is going to be formed, and it's going to be insoluble in excess. Okay, so if you see the difference between aluminium ion and calcium ion is aluminium ion, it's soluble in excess, well calcium ion, it's insoluble in excess. What about if you put ammonia? So there will be no precipitate, or there will be very slight white precipitate. So that's the behavior of calcium in excess aqueous ammonia. What about copper 2 ions? So for copper 2 ions, light blue precipitate is going to be formed, which is insoluble in excess sodium hydroxide. What about in aqueous ammonia? The same is going to be formed, but this one, it's soluble in excess, and it will give a dark blue solution in aqueous ammonia if you put it in excess. I mean, if you put aqueous ammonia in excess. So ion 2. For ion 2, in sodium hydroxide, it's going to form a green precipitate, which is going to be insoluble in excess. And if you put it in aqueous ammonia, it's going to give a green precipitate, which is also going to be insoluble in excess. So it has the same behavior in sodium hydroxide and in aqueous ammonia. Then ion 3. Ion 3 is going to give a red-brown precipitate, insoluble in excess. What about in ammonia? It is also going to give a red-brown precipitate, which is also insoluble in excess. Then finally, we'll take a look at zinc. So for zinc, it's going to give a white precipitate, which is soluble in excess, giving a KS solution. So zinc in aqueous sodium hydroxide, in excess aqueous sodium hydroxide is going to give a KS solution. What about in ammonia? It will give the same white precipitate, which is also soluble in excess, giving a KS solution. So this is how you tell these cations. Now there are some cations which give, when you do this, they give same results. So these are aluminium, lead 2, and zinc. So how to test this? You have to do about two processes or procedures. So you get whatever solution you are suspecting to have aluminium, lead 2, and zinc ions. So you add a few drops of aqueous ammonia and shake. So when you add a few drops of aqueous ammonia and shake, in all of them, let's say if there's just aluminium ion, or there's lead 2 ion, or there's zinc ion, a white precipitate is going to be formed. Next, you add excess aqueous ammonia. So when you add excess aqueous ammonia, there are two possible results. The first is a precipitate is formed which is insoluble in excess aqueous ammonia. If this is what happens, then you have aluminium ions or lead 2 ions. Well, if the precipitate is soluble in excess aqueous ammonia and it forms a clear solution, then it is the zinc ion, as just like we discussed. So that's how to separate aluminium ions or lead 2 ions and zinc ions. So now that you are able to tell that this is zinc, what about these two? How can you tell that they are different? The fact that they give you the same results in when you add few drops of aqueous ammonia and when you add excess aqueous ammonia. How do you differentiate them? So to differentiate these, you have to do one extra step. So the extra step is to add hydrochloric acid. So when you add dilute hydrochloric acid, aluminium is going to act with a chloride to form aluminium chloride, which is a chloride solution, and lead is going to form lead chloride, which is a white precipitate. So that's the difference. So if you add hydrochloric acid to the mixture, if the mixture now forms chloride solution, then it's aluminium that is present. But if it forms a white precipitate, then it's lead that is present. We go gases now. So for gases, we're going to start with oxygen, of course, which is represented by O2. So the color and smell of this gas is, it has no color and it has no smell. We breathe oxygen every day, but it does not smell. How do you test? You introduce a glowing splint in the test tube containing oxygen. So wherever you suspect that there's oxygen, you just introduce a glowing splint. A glowing splint is just a light. So you can get a matchstick. You light it and then you put it on your test tube. So what's going to happen is your glowing splint is going to be relighted. So it relights a glowing splint. This is the identity test for oxygen. The next gas is hydrogen, which is of course colorless and odorless. The test method is to introduce a burning splint in the test tube containing hydrogen. So hydrogen is going to burn the burning splint with a pop sound. So when you put your burning splint on the test tube, the opening of the test tube that has hydrogen, it's going to burn it with a sound like pop 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 pop. That's a pop sound. We go to carbon dioxide. So what's the color and smell of carbon dioxide? Again, colors and odors. How do we test? You bubble carbon dioxide into lime water. Lime water, the chemical name is calcium hydroxide. So you bubble carbon dioxide into calcium hydroxide and it will turn calcium hydroxide to lime water milky. We go to ammonia. So ammonia is different. It is colorless, but it has this very strange smell like rotten eggs. Yeah, that's the taste, or urine. That's the taste for ammonia. So what's the test method for ammonia? There's no test method, but actually you can get a test method. You can test by smelling. Once you smell it, you can tell that it is ammonia. Or you can use a red litmus paper, and ammonia is going to turn it blue. Since ammonia it's basic, so it's going to turn red litmus paper blue. Then chlorine. What's the color and smell of chlorine? So it is yellow and green in color. Also it's got a pungent smell. Test method, of course, you can do it, of course, using just the color you can tell and the smell you can tell. But of course, when you get the blue litmus paper, it turns a mouse blue litmus paper red, then it bleaches it. So the next is sulfur dioxide. So this one also is colorless and it has the same pungent smell. And of course, if you use the blue litmus paper, it will be turned it turns the most blue litmus red. It also turns orange acidified potassium dichromate green. So sulfur dioxide is an acidic oxide, therefore you expect it to turn blue litmus red. So for chlorine, sulfur dioxide, and ammonia, when it comes, you can differentiate using the colors. But of course, for ammonia and sulfur dioxide, they are all colorless, but they have nearly the same smell. So the difference is what they do to the blue litmus paper. Ammonia is going to turn it blue. It's going to turn the red litmus paper blue. While sulfur dioxide is going to turn the blue litmus paper red. For chlorine, from the color you can tell, and of course it turns the most blue litmus paper red, just like sulfur dioxide. So this is everything about qualitative test. Qualitative analysis. Hope you have enjoyed, and make sure you give it time to master all these identity tests. Otherwise, happy solving.